All right, so we're going to look at the 8 queens problem. I want to just go over the algorithm first, and then we're going to take a look at the code and how the code follows the algorithm. So basically, we have this chessboard, and what we're going to do is we have this array Q that we're going to write, and the array Q is essentially going to be spying, as we saw, on the columns. So here we're going to have an array Q. It's going to have the same number of elements as there are columns in the array. In other words, it's going to have 8 elements here. And what we're going to do is, in each one, we're going to write down the row for that column. So this is going to be 0, 1, 2, 3. Let me just change this for a second so we can see it more clearly. So this is Q sub 0, Q sub 1, Q sub 2. And in array Q, we're going to have the row number. So here we're going to put a 6. Q sub 0 is going to be a 6, reflecting the fact that in row 6 there's a queen. This here is going to be a 4, right? Because in column 1 there's a queen in 4. This is going to be a 2. This is going to be a 0. Next one's going to be a 5. Next one's going to be a 7. And then a 1. And finally a 3. So this array Q represents the state of the board. And now the algorithm, basically, what does the algorithm say? The algorithm says first create this array Q by creating a bunch of for loops. For loops are going to be populating the array Q. We're going to get this whole array Q. Initially it's going to start with 0, 0, 0, 0, 0, and so on, 8 zeros. And each time we generate the next one, we're going to be testing it to see if in fact it represents a valid configuration. There are 2 tests basically. This turns out to be a valid configuration. But let's say, for example, there would be a queen. We attempt to put a queen over here. In this box here. If we put a queen over here, that would mean there's a 0 here, and we can just look at this array and we'll see that that's not going to work, because if there's a 0 here and there's a 0 here, it means there are 2 queens on the same row. So one of the things that we want to do is we're going to be checking to see if there's a row conflict. In other words, for any of these, once we're pointing to some column, say we're pointing to column 7, we're going to see Q sub 7 is going to have some number. In this case, a queen here would be a 0 here. We check all the numbers to the left of it to see if there's going to be a 0 in any of them. So that's one of the tests. The second test is to see if the configuration is valid or not, is going to be whether or not there's a conflict in the diagonal. Well, this doesn't, because this is a valid configuration. But if there were a conflict, let's say, for example, I wanted to put a queen in this position. Say there's a queen right over here. Right? If there's a queen here, that means in column 5 there's a queen in row 2, so that will put, instead of the 7, that will put a 2 over here. Now if I have a 2 over here, there's going to be a conflict in this one. How do I detect such a conflict? So what I'm going to do is I'm checking the difference between these 2 rows. The diagonal means that the number of boxes I travel in this direction and the number of boxes I travel in this direction have to be the same. So how do I tell the number of boxes here? That's going to be the difference between the index positions. This is going to be column 5, column 3. 5 minus 3 is going to be 2. How do I tell the difference in the rows? The difference in the rows, well, these are the row numbers. So this is going to be row number 2. This is going to be row number 0. 2 minus 0 is going to be 2. So this is 2 and that's 2. That means there's going to be a diagonal over here. So that's basically what the algorithm, what the program is going to be checking for. But one other point has to be made is that since this is a really dumb algorithm in the sense that we have all those 8 for loops, that's going to start with a configuration of 0, 0, 0, 0, 0, right? 8 of these zeros. So aside from the fact that we're going to check for row and diagonal conflict, we want to make sure that there are no duplicates. Well, duplicates would mean rows. One way to test it is that way. But another way to test it is to simply see if the number of entries over here is going to be distinct. So in Python, what I can do is I can say take my queue, which is going to be a list, and make a set out of that list. And so if there were, for example, 2 3s in that set, the set would then shrink in size. If it started out, if the list had 8 elements, but there are 2 3s in it, lists are allowed to have duplicates, but sets aren't, so the size of the set won't be equal to the size of the list. So a different way to check to see if there's going to be a conflict in the row, namely if there's two elements that are the same over here, is to simply take the list, convert it to a set, and ask if that value is equal to the size of the list, which is 8. Okay, that's basically the idea. Let's see how the code actually implements that idea. So here's the code that we're working with. Basically what happens, we have these 8 for loops, and the for loops go in the range 8. 8 means it goes from 0 to 7, 0 to 7, 0 to 7, and the fastest moving loop is in the inside, the slowest in the outside. But what happens is I say I0 is 0, I1 is 0, I2 is 0. I'm going to get 8 of these zeros, and then I populate my list Q. Q is going to have the value of each one of these 4 indexes in turn, so it's going to start out 0, 0, 0, 0, 0, 0, 0, 0. The implication of that in terms of the picture of the queens is going to be queens for every column is going to be in row 0, row 0, row 0. Of course, that's ridiculous. But after we generate one of these things, we're going to ask the two questions. Do I have any duplicates? And is there a diagonal threat? Now notice this thing is an OR. And the way that an OR works is that the OR is going to be true if either of the two pieces is true. So if I have duplicates, I'm not even going to check to see if there's a diagonal threat. If there are no duplicates, then I'm going to go check for the diagonal threat. Now how does duplicates work? So we saw that a moment ago. Basically here is the duplicates function. The duplicates function says take the set Q. Now the set Q, take the array Q, take the list, and make that list. This list has the values initially of 0, 0, 0, 0. It has 8 values. They're all zeros. The size of that list, as I say, what's the length of Q? The length of Q is going to be 8. But when I take that Q and I turn it into a set, it's going to, if there's any duplicates at all, it's going to just keep one copy of the duplicates. So for the list that has all 8 zeros, the set of it will have only 1 0, so the lengths will not be the same. The length of Q will be 8, and the length of the set will be 1. So anytime there's duplicates, the length of the set will not be equal to the length of the one. And so we're going to return true. There are duplicates. When we return true, what's going to happen is we're going to continue. Continue means go back to the innermost for loop. And what you're not going to do is you're not going to count that as a solution and print it out. So in the beginning, I'm going to get all zeros, and then a bunch of zeros and a 1, and a bunch of zeros and a 2, and so on. It's going to take a while for this thing to start generating values that are not all 0. So what happens is once I start generating something like that, I'm going to keep checking these two functions. Are there duplicates and are there diagonals? So let's say I have a situation where there aren't any duplicates. That means all of the numbers here are then distinct. So this is the function. So duplicates is going to return false. There aren't any duplicates. But then I'm going to still have to test for a diagonal threat. Now how does the diagonal threat function work? Well, basically we walked through it a little bit before. What happens is it sets up 2 for loops, and those for loops are going to be working through and checking position against position. Let's take that and see that in terms of the diagram. So here's the diagonal threat program. So we have 2 loops. The outside loop starts column at 7. So this here is column 7. And what it's going to do is for column equal to 7, and it works its way down, it's going to column 7, column 6, column 5. The first column stays at 7. It's going to go into the innermost loop, and its column that's I is going to go from 0, 1, 2, 3. And so for column equal to 7 and I equal to 0, it's going to be comparing the value over here against the value over here. And what it wants to do is it wants to see if there's a diagonal threat. So it does exactly what we said before. It's going to check column, which is going to 7 against I, which is 0. So 7 minus 0 is 7. And it's going to check the insides, the q sub column, which is 3 against q sub I, so 3 minus 6 is 3 in the absolute value, so 3 is not equal to 7. So there is no diagonal conflict, because diagonal means that I have to go the same number of boxes in this direction as I do in that direction. And so for the fixed value of column on the outside at 7, it's going to see, does 7 conflict with any of these things on a diagonal? If the answer is true to any of those, if there is any diagonal conflict, then it's going to return true. It's going to go back to the program, and it's going to reject that as a solution. But let's say for that particular value of column 7, it goes through this loop and checks this against everything, and it says, well, 7 is not in diagonal conflict with anything to the left. If it comes outside and changes column to 6, in other words, it moves column from this position to this position, and it's going to check this position against everything to its left. If that's okay, column's going to be decremented again. It's going to start here, checking this against everything to the left. And if it doesn't find anything at all doing this process, so no, it will never return true. It will never say there is a diagonal threat. It's going to come out at the bottom over here, and it's going to return false. When it returns false, you're going to go back to the code, and what's going to happen at that point? Well, at that point of the code, you're going to increment the solution counter, and you're going to print the array. So that's going to be the situation right over here. You said duplicates, there were no duplicates, so this is false. Then the only way for this if to be true is if diagonal thread is true. But if it's gone through this whole thing over here and it never found a conflict, that was for no value of column, was there any conflict with anything to its left? So at that point, it's going to come down to the bottom as we saw, and right over here, it's going to say false. So if there was no duplicate conflict, and there was also no diagonal threat, so this thing is false and false, it's not going to do the continue. It's rather going to say count is incremented by 1, and it's going to come to the print, and it's going to print the word solution, and then count. Say that's the first one, it's going to say solution 1, and then it's going to print the list Q. After it does that, it comes back over here and keeps going and generating the next one and the next one until it goes through each one of the 8x8 configurations, right? As it does that, when it goes to the 8x8 configurations, anytime it finds, right, 8 to the 8 configurations, it's going to test each one of these things. If it finds, for every one it finds that there aren't any duplicates and there is no diagonal threat, it's going to print it out. So out of the 8x8, it turns out that in fact there are 92 different solutions where that's the case. That's the way this program works. So these things over here are generating all the possible combinations, all the way from 8 zeros, right? That's the first one. It takes each value of these things and puts it into Q. So it's going to be 0, 0, 0, 0, right? 0, 0, 8 of them. It's going to end up with 7, 7, 7, 7, 7, 7, 7, 7, and all of the values in between. That's the way the program works.